Hi, today I'd like to show you my colliding galaxy simulation. My simulation is capable of generating galaxies with thousands of orbiting stars. Let's start there. In my program, I've represented a galaxy as a JavaScript class with certain values like its mass, its position, its velocity, and finally its stars, the stars that are associated with this galaxy. Now really, stars and galaxies are mostly not intertwined. Every galaxy's gravity is going to affect every star on the plane. And you'll see that in a second when we show how galaxies cause each other to deform. But in our initial galaxy creation, what we wanted to do was create an effect where stars would orbit the galaxy. So what we did is we followed the formulas that we learned years ago in physics class, such as the acceleration due to gravity formula and orbital velocity formula. When generating a galaxy, we're going to find that we create thousands of stars, each in a position in a circle around our galaxy center. Then we're going to look at our function such as calculate acceleration, which calculates the acceleration due to gravity that's going to be applied to the star at each second, and calculate star velocity. Calculate star velocity calculates the necessary initial velocity of a star so that's in a stable orbit around the galaxy. It's not going to just fall into the center of mass. It's going to actually spin. And so once we generate a bunch of galaxies, we can then move on to the main loop of the application, where every galaxy center mass creates some gravity force on every single star in the program, and the stars are thus affected. And it's very interesting because, of course, gravity increases as objects get closer together rapidly. So you'll start to see at first that stars perfectly orbit their galaxies, then they start to deform themselves. Let's take a look at an example. This example started off really quick, actually, where we had two galaxies spawn very close to each other, so they immediately collided. Restarting, this example is a little bit more interesting. Both galaxies are started. One is larger than the other, but the smaller one has more dense with stars, and they both have an initial velocity. So instead of immediately colliding, you start to see deformation. The galaxies start pulling each other's stars, and the centers start pulling each other as well, resulting in an effect we often see, which is galaxies orbiting each other. This is a pretty classic collision here, and you'll notice that these point mass of stars are affected by both galaxies' gravity, and they start to go off in crazy directions. The effect of having gravity pull them together and then apart quickly causes many stars to be jettisoned into space, while a few remain orbiting around the close centers of the galaxies. Another interesting feature of this program is this configuration file. In this file, we're able to set lots of variables about the program itself, such as the number of galaxies on the screen, the size of the galaxies themselves, how many stars you can have, a minimum or maximum, it's a random generated range, and more interestingly, we can change the gravity constant, the collision constant, and the collision threshold. So the gravity constant, as you might see in the acceleration due to gravity formula, big G, is just a multiplier that in real life applies to objects to see how much force they attract each other with. In our program, changing the gravity constant allows us to change how fast things move, because in order for a star to orbit around a galaxy, it has to move fast enough to escape gravity, or to equalize gravity. And so in our program itself, having this custom gravity constant lets us speed things up or slow things down without actually having to change how many ticks we calculate. Same thing for the collision constant is when we have star centers collide, we don't want them necessarily to have no normal force and no collision, because then they'll go flying off into space. But we don't want them to just completely immediately clump together. Maybe they should hit and sort of drag each other around. And so what the collision course does is it provides an outward normal force when galaxy centers are collapsing, which causes the animation to be a bit more realistic. And now just for the end of the video, I really like this example because this large galaxy is being deformed but kind of at a slow pace, where the smaller galaxy is quickly forming a spiral shape as the large galaxy is kind of figuring out what to do with itself. Now they're starting to rotate around each other again, and if we use the keys, we can actually change the focus from one galaxy to another. That's all for now. Thank you very much.